Why do you just have a baby Mike?
Hey besties, we at the Alchemy Academy. Yeah. Tell us about your station.
Here we're talking about non-Newtonian fluids and just talking about the 3 states of matter. And a non-Newtonian fluid is something that doesn't follow normal Newtonian principles. Here we're going to be making oobleck, which is something that doesn't not follow Newtonian principles. Oobleck without pressure, it acts as a liquid, and once you apply force and or pressure, it acts more as a solid. And that's what we'll be making today.
How is your oobleck going? Would you like to talk into the tiny mic?
It's kind of...
Oh, it's very liquidy.
And it's also very hard to stir.
You got this. I have faith in you. I think your oobleck will turn out great. Who should we interview next? Oops, so sorry. Oh.
Hi.
Hello, Mateo.
Hi, what's up?
Tell us about your station.
We're making non-Newtonian matter stuff. So it's really cool because like when you punch water, it splashes everywhere. But when you punch this, it just goes all over your glove. Yeah, it's fun. Do you want some?
No, I'm okay. Thank you, though.
Okay. It's edible too. Just don't eat it. No.
It's edible. Just don't eat it.
Yeah.
In the wise words of our Mateo.
Yeah. Well.
Thank you.
Yeah. Thanks for the interview.
At the same time. Hello. Okay. Today at this station we are doing acid and base chemistry. You can see here we have a completed acid-base reaction between baking soda, sodium bicarbonate, and some 25% acetic acid, also known as super strong vinegar. Dump that out real quick. So basically what's going on is we've got a base right here and we've got an acid right here. We're putting them together into 2 different vials and you'll sort of see they both look clear. They both kind of look like water if you ignore the smell. And so there's not really an easy way to tell them apart, which is why we use some really handy things called pH strips. They turn different colors based on what the pH is, so they become more green when you put them in a base and they become more red when you put them in an acid. And just like the pH strips, a universal indicator will do the exact same thing. So instead of dipping a strip in, we can just put a couple drops in and the same thing will happen. Then what we do is we mix them together and we see that a lot of bubbles are going to form. Some gas is going to be released. It's just going to be this kind of reactive mixture that's foaming up over the top. So our question is, what's going on? Why is that happening? And the way I've been describing it is talking about the proton exchange. So bases are something that are lacking a proton and acids have an extra proton. The best way to think about this is sort of like a person with a football. An acid really wants to get rid of their football that they're holding, and a base really wants to grab a football that they don't have. So when they're alone, they can't either get rid of it or accept a football, but the minute you mix them together, the acids throw the football over to the base, which grabs onto it, and in doing so makes the reaction take place. So yeah, that's the baking soda and vinegar station. It's a lot of fun. There's cool colors, cool reactions. Definitely stop on by if you want to learn about some acid-base chemistry. Thank you very much.
Hello, my name's Rose.
My name's Kylie,
We are ice melting.
and we're testing hypotheses and predictions.
Woo! We are introducing what a hypothesis and prediction are and then having them write and say it to us with salt, sugar, and sand and our ice.
We're trying to test them to see what they think will melt the fastest in between the 3 substances.
Don't tell them, but it's proven that salt melts the fastest. Here's sugar. She's not doing much.
Sand's not doing much either, TBH.
But sugar, she going down fast.
No, salt.
I mean salt. Incorrect statement. Salt is going down fast. But yes, this is our station. It's very cool, you could say.
Science rules.
Bill Nye, the science guy.
Yeah.
Bill. Yep, that's our station. Okay, bye.
Dog is pretty chill over here. So what we're doing is we are freezing different things. We're getting the ice inside the structures we're getting the water to create ice crystals. And those crystals can shatter. So we take a gummy bear, we freeze it, we shatter it. We're also doing a balloon demo, which you take a balloon and we cool it down. And by cooling it down, the particles move slower and they take up less space, so the balloon will deflate. And then we're gonna pull it out and it's going to reinflate due to being reaccelerated. And that's station 5.
Okay, this is the Station 5 glow vials. We have a very cool chemical reaction here. Explain best.
So when we put the chemicals in the vial, we have a base and we have an activator. And then when we put the hydrogen peroxide in, the activator falls apart. And then that releases energy to a fluorescent dye. And the fluorescent dye releases light. And then you get to see it, and it's really cool.
Word on the street is that this is the coolest station. No bias here. It's just what we've heard. So, thank you.
Hello, I'm Johnny Cash. I have to explain the whole. Hang on, let me finish with these kids, and then I'll.
Hi, my name is Emma. Is this thing on?
Who are you, Emma?
I'm the president
Of what?
of the pledge class.
Which pledge class?
2023
Beta Alpha.
Beta Alpha. Look what I have in my pocket. Wow. It's glowing. Can you see? Super cool. Oh, ready to explain?
We are live at the scene of the iodine clock reaction. Can you focus? Sometimes when we do chemical reactions, what we need to do is it's not as simple as just taking one thing and turning it into something else. What we actually have to do is we have to change the composition of one of our reagents to make it into a shape that's actually useful. So I'm going to wash this out real quick. Let me just get set up here. So I have a little bit of starch solution here, and that's just like the normal starch that you'd have at home. So I'm going to pour some of this in. And in this beaker here, Erlenmeyer, I've got a dye. Now this dye is going to bind up to the starch. It is. The dye is going to bind up to the starch to make this really cool black solution, right? There's a problem though. The dye isn't in a shape that's useful to the starch right now, so it's not in a shape where it can bind up. We actually have to change the dye a little bit before we can make it useful. So let's make a prediction. What do we think is going to happen when I take this dye and I add it to the starch?
It's gonna change shape.
You're wrong. Nothing's going to happen, and it's going to stay the exact same color that it was. However, I know, it's chemistry. We have a little bit of sulfuric acid and hydrogen peroxide and water in here. What we're going to do with this is going to change the color, the composition, the shape of the dye and make it useful to the starch. So I'm going to just drop this in a little bit. Go ahead and take a look there. And notice, I'm going to add a couple drops at first, and notice how nothing happens. Nothing changes color. Because the dye is still turning itself into a shape that's useful for the starch. So if I dump all of it in, it just turns black right away.
Wow, that's pretty cool.
Thank you, it's chemistry. It changes color right away because we've done two reactions now. We've changed the dye into a shape that's useful and then attached the dye to the starch. This can also happen in other ways. What's in air, Emma?
I don't know.
Well, it's mostly oxygen and nitrogen. And the cool thing is we have some dyes that'll change color in the presence of oxygen. Hello, new student. So in this container, I have a solution with a dye that's yellow. And there's also a dye in here that changes color when there's oxygen nearby. Hey guys, give me just a sec here, okay? Dump this in. And notice how it already changed color just from the oxygen in the air when we poured it. Now it's back to the same yellow. But check.
Don't forget to get your diploma if you get all your stamps. And if you thought anything you saw here today was cool, you should come to Cal Poly and be a scientist.
Yay! So now we have a little jar here with some of our dye that's sensitive to oxygen and some of our yellow dye. But when I shake it, it's going to change color to green because all this oxygen's being added to solution and then it's bubbling right back out. Shake it a little bit more. It's going to bubble. See, there's little oxygen bubbles bubbling out, right? Once all those leave, it's going to go back to red. Once all the leftover oxygen bubbles leave, it's going to go back to yellow, which is just how it was at the beginning, and that's why it's called a stoplight, because it's red, green, and yellow.
All right, I think these kids wanted it too.
Yeah.
Thank you.
Thanks so much for waiting.
Hi. This is reporting live from Axe Academy, Axe Alchemist Academy. We've got lots of scientists walking around. I can see the future here. I have hope for our science in the future because of this moment. I'm working on the solubility station. It's phenomenal. There's all these different colors, and we're going to mix water and oil with soap. You know why that happens, because scientists. Yeah, pretty cool. Glad to be here.
Hey Brendan, are you ready for your tiny mic interview?
Yes. I'm stressed.
Please tell us about your station.
It's very messy. Yeah. My hands are very greasy. We put some water in a vial and they put some oil on top of that and they kind of saw the separation. And then, what's up? You want to say hi?
Hello.
Oh. Oh, okay. And then after that, they added some dish soap into their little vials, and that acts as an emulsifier. It allowed the oil and the water to mix. And yeah, that's why they do dishes. Cool.
Thank you.
Science behind chores.
Now let's pass it off to Sal with the weather. It's cloudy here in San Luis Obispo. Slight chance of rain, 22% in the evening. It'll be a cool night tonight. Lows in the 40s. And get bundled up. Next weekend's going to be cold. Take it easy. I'll hand it back. I can't do this.
You want to interview?
This is fun. This is fun. It's you get to do lots of cool science experiences here. And yeah.
Hi. What do I do now? I don't know what I'm doing.
What's been your favorite thing so far?
This thing. Yeah.
How has your experience been at this event?
I've been here for about 10 minutes, and I've gone to every single station. Did I do them? No. Did I watch the kids do them? Yes. Are the kids so excited? Yes. The kids are so happy.
Would you like to have a brief little tiny mic interview? Sure. All right, cool. You guys want to tell us about how your experience was and what your favorite station was?
It was fun.
All right, cool. Yeah. Which one did you like the best?
The last one, number 7.
How about you? Which one was your favorite?
I probably
the
the
glow stick one. Thank you for coming. We're finding our next victim to interview. Yo, they cooking. They cooking.
Why am I being interviewed? I was gonna ask Jay the question. Okay, how was it being a VMA for this Pledge Plus?
It was a good time. They made it really easy.
Nice.
They're doing us proud. Would you guys like a tiny mic interview? Yeah? Here you go. Which was your favorite part?
Station 1.
Station 1? The oobleck one? What color did you make your oobleck?
Blue.
Blue? Is blue your favorite color?
No, it's purple.
Thank you so much.
Wait, so is it loud?
In the baby mic? If you talk into it, yeah. You want to have a brief interview into the baby mic?
Yes.
All right. How was your time here at Alchemy Academy?
Good.
Was it good? Which one was your favorite station?
The first one.
The first one?
Glow stick.
The oobleck one? What color did you make yours?
I made mine, I don't remember. I think it was blue.
Oh, real. Do you like blue?
I like orange.
You like orange? We'll make that note for next time.
Okay.
Look at my non-Newtonian fluid. We.
The behind the scenes. Christy, document everything. Don't shut the camera off. They need to see.
I was surprised.